Hello students, in this video we are going to see about homogeneous linear differential equations of higher order with constant coefficients. This is a general homogeneous linear differential equation. This is of order n. A naught dny by dx power n plus a1. This is the n minus 1th derivative of y with respect to x, and this is n minus 2th derivative of x, etc. up to a n y equal to 0. In this, if I use the symbol capital D is equal to d by dx. If I replace capital D as d by dx, here we have the nth derivative. So I can represent that as a naught into dn plus a1 dn minus 1 plus etc. up to the last term is an, everything into y equal to 0. Here capital D is called the differential operator. This is a function of d, that is in terms of t. I can say this as a function of d into y equal to 0. So this equation only we are going to solve. Solving the equation means we are going to find what is my y in terms of x, a function of x. Like this we have to get an answer. For that, first we have to write the auxiliary equation of the given differential equation. How to write the auxiliary equation? In the equation we have to replace every capital D by m. After replacing that, we have to find the roots of the given differential equation. Based on the roots, we have some cases. Based on the roots, we have to write the final solution. If case number 1 is, if all the roots are real and different, distinct roots. For example, if we have n roots, all the roots are different. Let the roots be m1, m2, etc. mn. All the roots are different. How to write the final solution? Y is equal to constant c1, c2, etc. cn are all constants. We can use symbols c1, c2, etc. cn or a, b, c, d, etc. Okay, so c1 e power first root into x plus c2 e power second root into x plus etc. up to cn e power mn x. This is the case when all the roots are real and distinct roots. The second case is all the roots are real but some roots are repeated. For example, if two roots are repeated, the first two roots I have taken as same, m1 and m2 are repeated. From the third root, all the other roots up to the nth root, all the roots are different. How to write the final solution? The first two roots are repeated, so we have to combine the first two constants together. So how to write the final solution? Y is equal to c1. We have to start with c1 plus c2 into x. Everything into e power, which root is repeated, either m1 or m2, anything we can say, since both are having the same answer, m1 into x I have written. From the third root, as usual, what we have in this case, no, like that we have to write. So c3 e power m3x plus c4 e power m4x plus etc. up to the last root is cn e power mnx. Suppose three roots are repeated, means we have to combine three roots together. So c1 plus c2x plus c3 into x power 3. Everything into e power, the which root is repeated? No, m1x. That we have to combine if three roots. If we have the fourth root also equal, means we have to extend this. Plus c4 x2 x power 2 we have, no, the next one is x power 3. Like that we have to take up to how many roots are repeated. So some roots are repeated, means in this way we have to write. The next case is if the roots are imaginary. Imaginary means like alpha plus I beta. Here two roots are repeated. I'm sorry, not repeated. They are imaginary roots. So first root is alpha plus I beta. The second one is alpha minus I beta. How to write the final solution? Y is equal to e power alpha x. Alpha means the real part. Alpha into x into c1 cos beta x plus c2 sin beta x. For c1 and c2 we can replace the constants by a and b. But this is the general format. E power real part into x into a constant into cos beta x plus the next constant into sin beta x. This is the case when the roots are imaginary. So the problem number 1 what we have is we are going to solve the equation d squared y by dx squared plus 5 dy by dx plus 4y equal to 0. How to start? First we have to write the auxiliary equation. So the auxiliary equation is, this is the auxiliary equation. For this we have to find the roots. Directly we can find the roots, or we can factorize and we can find the roots. What is the sum of the roots? We have 5 and the products of the roots is 4. What are the factors for 4? 4, 1, then minus 4, minus 1. Here this only will give the sum 5. So I can rewrite this as m squared plus m plus 4m plus 4 equal to 0. When I add up this, I'll get 5. So this one I have selected no. So I didn't write 4 first because here we have 4. If I write this, I can take 4 outside. So in that case only I have changed this term as 1 and this term as 4. Now combining these two together, I can take m outside. So m plus 1 is the balance. Here m, here 1. In the second term I have taken 4 outside. So after taking 4 I have m and here 1, which is equal to 0. These two are having m plus 1 common. So m plus 1 into the balance here is m and here it is 4. M plus 1 into m plus 4 equal to 0. So m plus 1 equal to 0 or m plus 4 equal to 0. So either m equal to minus 1 or m equal to minus 4. From here, if you want to say the roots directly, means if it is plus 4 plus 1, we have to give the answer as minus 4 minus 1. Or in this way, we can write the factors and we can find what are the roots. Here both the roots are different. So how to write the final solution? Solution y is equal to constant c1 e power first root into x. Minus 1 into x is minus x plus c2 second root minus 4 into x. Or I can say a e power minus x plus b e power minus 4x. And this is the final solution. Is it clear? Here we are going to solve d squared y by dx squared plus 2 dy by dx plus y equal to 0. How to start with? We have to write the auxiliary equation. This is the auxiliary equation, m squared plus 2m plus 1 equal to 0. Product of the roots is 1 and sum of the roots is 2. So 1 has factors 1 and 1. If 1 and 1 are the factors, the roots are minus 1 comma minus 1. This is the direct how to find the roots directly, or else from here no, we can start m squared plus 2m plus 1 equal to 0. I can expand this 2m as m squared plus m plus m plus 1. Both the terms are having m common. After taking m outside, m plus 1, and here only 1 I can take outside, so m plus 1. Now these two m's m plus 1 I can take outside. Then the balance here it is m, here 1, m plus 1. So m is equal to minus 1 and the second case is also minus 1. So directly we can find in this way or we can find in this way. Here these two roots are repeated. So how to write the final solution? If two roots are repeated means we can write y is equal to c1 plus c2 into x. Then e power, the repeated root is minus 1 into x minus x, or we can say a plus bx into e power minus x. This is the final solution. Here two roots are repeated. Is it clear? The next problem what we have is d squared y by dx squared minus 3 dy by dx plus 5y equal to 0. So we can rewrite this as d squared minus 3d plus 5 into y equal to 0. This is the auxiliary equation, m squared minus 3m plus 5. Product is 5, sum is minus 3. 5, sum is minus 3 means 5 factors are 1 and 5. When you add or when you subtract, we are not able to get this minus 3. So we have to use the formula method for finding the roots. What's the formula? Minus b plus or minus root of b squared minus 4ac by 2a, where a, here a is the coefficient of m squared, that is 1, b is equal to the coefficient of m, that is minus 3, and c is equal to the constant term 5. Therefore, m is equal to minus b. Minus b means minus of minus 3, so it is plus 3, plus or minus root of b squared. What is my b squared? It is minus 3 the whole squared, 9, minus 4 into 1 into 5 by 2 into 1, that is 2. So 3 plus or minus root of 9 minus 5 into 4, it is 20 by 2. 9 minus 20, it is minus 11. So this is equal to 3 plus or minus root of minus 11 by 2. Minus root 11 can be written as 3 plus or minus I into root 11 by 2. How we are taking this I? Already we know that root of minus 1 is equal to I. I squared is equal to minus 1. Taking square root on both sides, we are getting I is equal to root of minus 1. So within the root we have a negative sign. For that I am using the symbol I. So now we got the roots as 3 plus I root 11 by 2. That is my one root. The other root is 3 minus I root 11 by 2. So these are the roots. 3 plus I root 11 by 2, 3 minus I root 11 by 2. I have rewritten in this way: 3 by 2 plus I root 11 by 2, 3 by 2 minus I root 11 by 2. This is my alpha and this is my beta. So alpha is equal to 3 by 2 and beta is equal to root 11 by 2. So how to write the solution? Therefore, the solution is y is equal to, what's the formula? E power alpha x. So e power 3 by 2 into x into c1 cos beta. Beta is root 11 by 2 into x plus c2 sin root 11 by 2 into x. For c1 and c2, as usual, either you can use c1, c2 or ab. So this is the solution. Is it clear? The next problem what we have is 2d squared y plus 5d minus 6y equal to 0. From all the terms, I can take y outside. After taking y outside, I have 2d squared plus d minus 6 into y equal to 0. So what's my auxiliary equation? 2m squared plus m minus 6 equal to 0. The product what I have is minus 12 and sum is plus 1. 2 into minus 6 minus 12. Here the sum is plus 1. What are the factors for 12? For getting minus 12, 1 into minus 12 or minus 1 into plus 12. Then 3 into minus 4, minus 3 into plus 4. 6 into minus 2, minus 6 into plus 2. These are the factors for getting minus 12. Here, which will give the value plus 1? Minus 3 plus 4. Product of these two will give minus 12. Adding these two will give plus 1. So this one. If the coefficient of the higher power is not equal to 1, if it is not 1, directly we are not able to factorize, directly we are not able to write the roots. We have to expand. This m can be written as, what are the factors we took? Minus 3 plus 4. This m can be written as plus 4m minus 3m. Combining these two will give the result plus m. Minus 6 equal to 0. Since I can combine 3 and 6 together, I have taken 3 here, and I can combine 2 and 4 together, so I have taken this order. Now taking 2m as common factor, here I have m, and after taking 2m, here I have 2. Then here minus 3 I can take outside. If I take minus 3, the balance is m, and minus 3 I have taken, so m plus 2 equal to 0. Both the terms are having m plus 2. 2m is the balance term, and here minus 3. equal to 0. So m plus 2 is equal to 0 means m equal to minus 2. And 2m minus 3 equal to 0 means 2m equal to 3, m equal to 3 by 2. So m equal to minus 2 and m equal to 3 by 2, both are distinct roots. So how to write the final solution? Y is equal to c1 into the first root is minus 2. So e power minus 2x plus c2 into e power 3 by 2 into x. Is it clear? The next problem is d cube plus d square plus 2d into y equal to 0. So we have to find the auxiliary equation first. M cube plus m square plus 2m equal to 0. I can take m outside. So m square plus m minus 2 equal to 0. So either m equal to 0 or m square plus m minus 2 equal to 0. Now we have to find the roots. Here sum is plus 1. Product is 1 into minus 2. It is minus 2. So for getting plus 1, we have to find what are the roots, that is what are the factors for minus 2. For getting plus 1, I can write 2 minus 1. Product of this will give minus 2. Adding this will give plus 1. So what are the roots for this? If it is plus 2 minus 1, roots are minus 2 plus 1. Right? Already we have one root 0. So finally we got the three roots 0, minus 2 plus 1. How to write the final solution? All the roots are different. So c1 e power 0x plus c2 e power minus 2x plus c3 e power x. Anything power 0 it is 1. So c1 plus c2 e power minus 2x plus c3 e power x. This is the solution. The next sum what we have is 2d squared y minus 2dy minus y equal to 0. This is the auxiliary equation. 2m squared minus 2m minus 1 equal to 0. Product is minus 2 and sum is also minus 2. Minus 2 means 2 minus 1 or minus 2 plus 1. Anything if we add, no, this when we add this it is plus 1 and this is minus 1. We are not able to get this. So we have to use formula method for finding m. What is the formula? Minus b plus or minus root of b square minus 4ac by 2a. Minus b means minus of minus 2 plus 2 plus root of plus or minus root of 2 minus 2 the whole square, it is 4 minus 4 into a into c. Minus in c also we have one minus. So minus into minus plus. So plus b squared minus 4ac. So 4 into 2 into minus 1, that is 1. We have added that minus here by 2 into 2. A is 2. So 2 plus or minus 4 2s are 8. 8 plus 4 12 by 4, which is equal to 2 plus or minus root 12 can be written as 4 into 3 by 4. This can be written as 2 plus or minus root 4 root 3 by 2. Root 4 is plus 2. So 2 plus or minus 2 by 2. From the numerator I can take 2 outside. So 1 plus or minus, here I missed this root 2, root 3, root 3. This is also not 2, it is 4. This is 4. I'll write here. So from here I'm going to start 2 plus or minus root 4 is 2, root 3 by 4. I can take 2 outside. So 1 plus or minus root 3 divided by 4. I can cancel 2. So 1 plus or minus root 3 by 2. So the roots are 1 plus root 3 by 2, 1 minus root 3 by 2. These two are not imaginary roots. These are real roots and different roots. Imaginary means it will have a I part, that is imaginary part. Here it is a real root. So how to write the final solution? y is equal to constant e power the first root 1 plus root 3 by 2 x plus c2 e power 1 minus root 3 by 2 into x. This is the solution. Is it clear? The next problem what we have is d power 4 minus 6d cube plus 12d squared minus 8d. So what's the auxiliary equation? M power 4 minus 6m cube plus 12m squared minus 8 into m equal to 0. All are having m common, so m cube minus 6m squared plus 12m minus 8 equal to 0. So either m equal to 0 or m cube minus 6m squared plus 12m minus 8 equal to 0. So totally we have to find 4 roots. One root already we got, that is 0. The remaining 3 roots we have to find this from this cubic equation. This is the method what we are using for finding the roots of a cubic equation. We have to write the coefficients in order. The first coefficient is plus 1, second coefficient is minus 6, then third is 12, and this is minus 8. We have to substitute values from plus 1, minus 1, plus 2, minus 2. Like that we have to start. So I'm going to start with 2. So first I have to take 0, then adding these two 1. First I have to start with 0. 1 plus 0 is 1. Then we have to multiply these two. 2 into 1, it is 1. Now we have to add these two. Minus 6 plus 1 is minus 5. Then 2 into minus 5, it is minus 10. 12 plus minus 10, that is 2. 2 2s are, I'm sorry, here I made a mistake. 1, this is 1. 2, this is 2. Here it is 2. So minus 6 plus 2 is minus 4. Then 2 into minus 4, it is minus 8. Then 12 minus 8, it is 4. 2 4s are plus 8. Minus 8 plus 8 will give the remainder 0. So I can say 2 as one root. Already we have 0 as a root. Now 2 as a root. From here itself I can extend, or I can make this as a quadratic equation. Then I can find the roots from the quadratic equation. So m squared minus 4m plus 4 equal to 0. M squared minus 4m plus 4 equal to 0. This is product is 4, sum is also minus 4. So I can rewrite this as m squared minus 2m minus 2m plus 4 equal to 0. Minus 2 into minus 2 plus 4. So I have taken this, I have rewritten. Then m I have taken outside. After taking m minus 2, and here minus 2 outside. So m minus 2. M minus 2, m minus 2 common. So m minus 2 is the balance. So m equal to 2 comma 2. Already we have two roots, 0, 2. Now 2 comma 2. Totally it has 4 roots. How to write the solution? Out of the 4 roots, 3 roots are repeated. 1 is the different root. So we will start from the different root. C1 e power 0x plus 3 roots are repeated. So C1 plus C2 into x plus C3 into x squared. Everything into the repeated root is 2x. This is the way how to write the final solution. Is it clear? See you in the next video. Thank you.